So let's quickly recap, okay, what we did before the break. Right, the main point that you need to memorize is the horizontal asymptote, right? N less than D is always y equal to 0. N equal to D, then horizontal asymptote is quotient of coefficient. Okay, so make sure you remember that. And then we looked at two special questions that has two vertical asymptote, right? They look very different. Okay, so let's look at type 3 now. Type 3 is the one that has numerator degree bigger than denominator, right? So this one has n equal to 2 and d degree is 1, right? So you know it belongs to type 3. So for type 3, the asymptote will be different as well, right? It will also have a different rule, okay? But vertical asymptote is always the same way, right? So you take the denominator, right? Denominator equal to 0, so x equal to 2. So vertical asymptote, the method to find it is always the same. Now for horizontal asymptote. So you can imagine, right? Let's try that subbing in a big number again, right? If you sub in 1,000, okay, I would like you guys to try. Can you raise your hand after you sub in 1,000? Okay. So f of 1,000. Close to what? Okay, Donna, what do you have?
1002.008016.
Okay. So something really big, right? So
Yeah.
feels like this one is not really approaching to a small number, right? If I try to sub in instead of 1,000, if I try to sub in 10,000, okay, I believe it will get even bigger, right? The bigger you sub in, the bigger it gets. So it's not really approaching to a certain number. So this one, whenever n is bigger than d, you would have no horizontal asymptote. Okay, so this one has none. So that's your type 3. Okay, however, we have another kind of asymptote that only exists for type 3. Okay, so this one is called slant asymptote. Okay, some textbook they also call it the oblique asymptote. Okay, so slant I think is easier to say, right? So SA, okay? So slant asymptote is only when n bigger than d, but n cannot be too big, okay? N has to be bigger than d by 1 only. So for example, this one has n equal to 2, right? D is 1, it's only bigger by 1, right? Or if you have 3 and 2, right? Or 4 and 3, bigger by 1, then you get slant asymptote. Okay, so let me erase that. So let's write that down. So n is greater than d by 1. Okay, that's a rule for getting a slant asymptote. Otherwise, you won't have slant asymptote. And to find the slant asymptote, okay, slant means the asymptote will go diagonally, right? Either going this way or going this way, right? Linear, okay, will be straight lines, but going instead of horizontal and vertical, we have diagonal ones, okay? So since it's an equation of a straight line, it will equal to the quotient of the rational function. rational function. Okay, because this function here, right, x squared plus 4 over 2, over means divide, right? So when you divide it, the quotient is called it will give you the slant asymptote, okay? So I like to just remember it's the quotient, okay? I'll highlight that part. Slant asymptote is when you have y equal to quotient, okay? And then horizontal asymptote is always none, okay? Whenever it's type 3. But slant asymptote is when n is greater than d by 1, okay? So sometimes you get slant, sometimes you don't, okay? So you got to check the rule. But in grade 12, okay, if you don't have the horizontal asymptote, I think most of the time, I would say 90% of the time, you will get slant asymptote. Okay. Right. And then now we need to find it, right? So to get a quotient, right, we need to do dividing. So x squared plus 4 divided by x minus 2. So does any one of you still remember how to divide this? How to do division? Cindy, do you remember how to divide these two?
The thing we learned last week, like the
Yeah,
polynomial.
sort of, yeah. So what's the method? What's the way to do it?
Do like x minus 2 equals 0 first.
Yeah, x minus 2 equal to 0 give us x equal to 2, and then?
And then do the synthetic.
Yeah, very good. Yeah, synthetic, that's the word, okay? Synthetic division, okay? You can write it down. Synthetic division. Okay, so let's draw the box. And I'll let you guys do the synthetic division, and please write down the quotient and raise your hand, okay? And don't forget this one, you need to add in 0, okay? I don't know if you noticed or not, right? Because you have a term that's missing, okay? Don't forget to add 0 if it's missing a term. So when you found a quotient, please raise your hand. Okay, so inside you should put 1, right? Dividend is 1, and then missing the x, right? So you put 0 and then 4, okay? I hope you haven't forgot the synthetic division. Okay, so Tiana, what do you have for the quotient?
X plus 2.
X plus 2. Okay, so we'll put that over there. Y equals to x plus 2. So this line is going to be our slant asymptote. Okay, so let's check your division now. 1 drops down, and then put the 2, add it together, right? And then 4, and then you have a remainder of 8. But we don't care about the remainder, okay? We just look for quotient. Any questions so far? Okay, let me separate this, okay? Separate the, yeah, okay. So now next part we want to find is the domain range, right? So let's write that down, domain and range. Okay, domain is same thing. It is the opposite of the vertical asymptote. Cannot be 2 and real number. And because we don't have horizontal asymptote, right? So there's no empty space horizontally, right? So this one will be all real number, right? You will be able to find y value everywhere, okay? And then number 3 is the intercept, okay? X-intercept and y-intercept. So same thing, this is your work now. So please raise your hand when you found the intercept. Okay, Donna, what do you have for x-intercept?
None.
None, okay, yeah, that's correct. Okay, x squared plus 4, you make it equal to 0, but then it's unable to solve for x, right? You cannot square root a negative number, right? X squared will be negative 4, you cannot square root that. So no x-intercept, okay, no. Tiana, how about y-intercept?
Y equals to -2.
Y equal to -2. Yep, that's good. So f of 0 equal to -2. All right, so we got everything we need. So let's draw the graph. We have x equal to 2 is our vertical asymptote, right? So that's the middle point. Okay, and then, so this time, make sure you have to draw the slant asymptote. Okay, so you better know how to draw y equal x plus 2, okay? The 2 is the y-intercept, okay? And the slope, right? You can use the slope. Slope is 1, okay? So get the table first, right? So you can pick points around it. You can do 1 and 0, okay? 3 and 4, okay? That should be enough. Okay, so when you finish the table, please raise your hand. One, two, three, four. And you can continue, right? Once you finish the table, right? If you're sure, you don't need to check with other people. You can go on, draw the asymptotes and plot the points, okay? Raise your hand if you finish the table. Okay, Cindy, what do you have for 0 and 1?
-2 and -5.
Okay, thank you. And Eric, what about 3 and 4?
13, 10.
13 and 10. Wow, that's big. Okay. All right, so that means I need to extend then. Okay, I need to extend my graph. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. All right, so let's plot the points. We have, we need to draw asymptote first, okay? So 2, 0, 2 is undefined, so 2 is here. Okay, and then y equal x plus 2. So you have a y-intercept of 2, and then slope is 1, so it goes this way, right? Okay, so your slant asymptote is like this. Okay, any questions? All right?
Wait, slope is 1, right?
Yes. mx plus b, right? So y equals to mx plus b. The b is the y-intercept, and slope is the m. So up 1, right 1, okay? And then follow the table. We have 0, -2. 0, -2 is down here. 1, -5. 1, 2, 3, 4, 5. Right? 3 and 13. So 3 all the way up there, 13. 4 is 10. So about here. Okay, can you raise your hand if you got all the asymptotes at the point? And then we'll draw the curve together, okay? Once everybody got the point. Cindy, Eric, Samantha, have you finished the points? Yeah, okay. So the way to curve, right, is just to draw the curve, draw the graph going through those points and get closer and closer to the asymptotes, right? And let's just make sure, do we have any intercept? We have y-intercept of -2, right? That's the only one, okay? So we know that, right? So we just draw the curve for the bottom one. So curve like that and goes down, right? So it doesn't touch the x-axis. That's why there's no x-intercept, right? And then for the top part, we'll go like this and bend. Right, so of course it will continue getting closer and closer to the vertical one, okay, as we go up higher. All right? Okay, can you raise your hand if you have finished the graph? All right, so question B is the same, okay? We're going to skip question B. It's nothing nothing tricky for question B, okay? You follow the same thing, you do long division, sorry, synthetic division, right? Then you can get a quotient, then that's also the slant asymptote, right? So you will have practice for homework like that. Now let's look at type 4, okay? So remember type 4 is something that you can combine with 1 and 3, right? So inside type 1, it could have something called point of discontinuity. I call that pod, okay? So let's see when do we get that and what it looks like on the graph. So when you see this question, compare with other one, right? You always, when you study, right, always compare, try to find the difference. If you look at this one, right, x squared minus 4, right? Very similar to the left side, x squared plus 4, right? The previous question. What do you think we can do to start? Is there anything we can do before we do anything else? Right, before we proceed to do the asymptotes? When you see x squared minus 4, have you learned something to do with that? Anybody?
Difference of square.
Yes, very good, okay? It's something that we could factor, right? So whenever it's factorable, it is possible to have point of discontinuity. We had an example that is factorable, right? I think like this one, right? Question B down here. This one is factorable, right? X plus 1, x minus 2. But then after you factor, nothing can cancel out, right? Let's look at another one, okay? This one. Okay, this one we also did the factoring, right? The top was x minus 4, x plus 1, right? And denominator was x plus 2. But then nothing the same, right? Nothing can cancel out. So nothing you can do. But for the one we are trying to do here, if I factor the top, okay, so this one we can simplify. Okay, simplify by factoring. So the top, how do I factor this one, Tiana?
X minus 2 and x plus 2.
Yes. Okay, so x plus 2. Then you'll see that compared to other ones, right? Other question after you factor, nothing can cancel out. But then this one, we can cancel out the x minus 2. So that's what's creating the point of discontinuity. Okay, so after I canceled out, the function now simplifies to x plus 2 only. So that means when you are graphing, you are not graphing the original one. You are graphing the one that's simplified. Okay? So make sure you write this down. Graph this. Okay? You must graph the simplified version, not the original one. So if you look at this one now, it doesn't look like rational, right? So do you have asymptotes? Cindy? Cindy,
Hi. Oh, what was the question again?
did you go away? Do you have asymptote for this?
No.
Because
There's like no degree. Well,
no,
there's a degree, like there's no like skirt or anything.
not because of that. Think about how you find the vertical asymptote, horizontal asymptote.
Oh, there's no denominator.
Yes, okay, it's no longer a rational, right? If it's a rational function, then there is asymptote, right? But this one, it becomes a linear. So your final graph will look just like a line, okay? Because you simplified it. So your number one, right? Number one, it asks you to find asymptotes. So vertical asymptote, horizontal asymptote, it will be both none. Okay? If it simplifies to linear. But if you simplify it and it becomes a rational, then you will still have vertical asymptote, horizontal asymptote. Okay, so it all depends on after you simplify, right? Every other question we did before, you cannot simplify, right? Even factoring, you cannot simplify, but this one you can, right? Any questions so far? Okay, number 2, we need to find domain range, right? Domain range. Okay, now for domain range, because this is a linear line, right? So linear line can goes everywhere. So looks like it's all real number. But then because the question, it came from this one. Okay, so you cannot forget the past, right? Otherwise you are changing the question, right? So in the past, before you simplify, you still have restriction there. So you need to keep that in mind. So this one, the restriction for the original is what? Eric? What's the restriction for the original function?
X include or
How do you find restriction?
is it
You know,
I
where
don't
do you look for restriction?
know.
Restriction means something that you cannot have, right? You cannot equal.
Denominator.
Yeah, very good. So what about the denominator?
You have x minus 2 equals 0. Right?
But we cannot have denominator equal to 0, right?
Yeah.
So that means x cannot equal,
2.
yeah, so that's called the restrictions, okay? So you have to keep that in mind, even though the graph we are drawing is a linear, right? Linear doesn't have restrictions. So domain range is supposed to be real number, but the original question, you cannot ignore that, right? So you have to include that. You have to still say x cannot equal to 2, and x can be everything else. Okay? And then when x cannot equal to 2, right? Because we're drawing the linear line, okay? Let's draw it out first, okay? And we'll come back to talk about the range. Otherwise, range will be confusing, okay? Let's draw this line first. So 1, 2, 3, 4. 1, 2, 3, 4, right? Because this one is a linear. I don't think we need a table, right? So can you guys raise your hand if you finish drawing the line? X equal, that y-intercept is 2, slope is 1, right? So it's the same as the asymptote line that we did before, right? But instead we have to connect all the points. Okay, please raise your hand if you finish drawing the line. Okay, Cindy, Samantha, have you finished drawing the line? Okay, so back to the domain range, right? We said that the domain x cannot equal to 2. So 2 is here. So that means you go up, and then on the line, you have to dig a hole. Okay, that's why it's called the point of discontinuity. So at 2, right? Okay, so that means I need to redraw the line here. Okay. Oh, this one. So at 2, I need to go up and dig a hole there. Right? Empty hole. Okay, so your graph will have the empty circle. So that circle there is called the point of discontinuity. Okay, and we need to know where it is. The x value is 2, and that empty hole is on the line, right? So we can plug the 2 into the equation of the line, right? So 2 plus 2 makes it 4, right? As you can see, it's at 4. Okay, so you are finding the empty dot, okay? The point of discontinuity. So that means your range is y cannot equal to 4. Okay? And to figure out the 4, right, let's make a note, right? To find the 4, you will sub x equal to 2 into the function that you simplified. Okay? That's how we found the 4. Any questions? Okay, can you raise your hand if you understand how we found the 2 and 4? Okay, so the simplified is to help you to graph it. But when you try to find the POD, you need to look at the original, okay? Because otherwise you are pretending it doesn't exist, right? Right, now let's look at the number 3. Number 3 is the x-intercept, y-intercept, okay? X-intercept, y-intercept is talking about the simplified one. So looking at the picture there, right, x-intercept is at -2, right? Because it's straight line, easier to see, right? Y-intercept is at 2. Okay, so if it's linear, it's pretty easy. Number 4, okay, so finally we have a number 4 here, right? This is a POD. So POD is at 2, 4. Okay, so this is the new thing here, finding the POD. So let's write it on the top, okay? How do we find the POD? How do I know the question has POD or not? Okay, so we can write this down when rational function is simplified, when rational function can be simplified, okay? Can be simplified. Okay, can be simplified means something canceled out. If something canceled out, then you get an empty hole. Okay, so that's the rule to tell. So you could combine this with any one of the type 1, 2, 3, right? Any one of type 1, 2, 3. If something canceled out, then you know you will have a POD, okay, a pod. All right, so let's try a question below. Okay, so looks like we can do some factoring and then see what happens, okay? So I'll let you guys try factoring, and when you finish factoring and simplifying, please raise your hand. Please raise your hand if you have finished factoring and cancel out, okay? All right, so let's check the factors. Donna, what do you have for the numerator?
2x plus 3.
2x plus 3, and the other one?
X minus 1.
X minus 1, okay? And Cindy, denominator?
X minus 4 and x minus 1.
Okay. Anyone got different? Looks okay. Right, 3x minus 2x. Yep, okay, looks good. So looks like we can cancel out the x minus 1, right? So that's where the POD appear. And then after you cancel out, you get 2x plus 3 over x minus 4. So make sure this is the one you graph. Okay? And since we're graphing this one, then you go back and think about, does the one we are graphing right now, is it type 1, type 2, or type 3? Okay, can you think about this? Is this one type 1, 2, or 3? Tiana, what do you think?
2.
Yep, type 2, okay. So type 2 is when the degrees are the same, right? Okay, so once you know it's type 2, then I'll let you finish everything from 1 and 2, okay? 1, 2, 3, okay? I'll let you do 1, 2, 3. We can talk about POD together, okay? So raise your hand when you finish 1, 2, 3. Okay, let's check vertical asymptote. I think you guys got the vertical asymptotes, right? At this time, I compare with the last one, this time is not a linear, so we would have asymptotes now, okay? Because we are graphing a rational. All right, so Eric, what's your vertical asymptote?
4 and 1.
You have to tell me the variable.
X equals 4 and 1.
So you have 2 vertical asymptote. X equal to 4 and x equal to 1.
Oh, no, just x equals 4.
How come?
Because we use the simplified version to
Yes,
graph.
very good. Yeah, okay. So that's why I circled it, right? And I put the exclamation mark, right? So you only focus on the one you want to graph, okay? The original is only for you to find the POD, okay? Before cancel, right? It's for you to find POD. So be careful, right? We only have one vertical. Okay, and what's the horizontal asymptote, Donna?
Y equals 2.
Yes, very good. Okay, you look at the coefficient. Coefficient on the top is 2. Denominator is 1, so 2 over 1. Okay, domain. Okay, domain, of course, we have to include x cannot equal to 4, right? Range, we have to include that. Y cannot equal to 2. But there's more. Okay, Cindy, where is the other value that it cannot equal to for x?
Wait, I just got the x can't equal to 4.
Only 4?
Yeah.
Oh, okay. Anyone else? Only
1.
4 and what?
1.
1. Okay, Donna, can you tell us where we got the 1?
The can you circle it
Yeah, you can circle it.
here? Oh wait.
How did you get the 1? Wow.
Here.
Okay, over there. Yeah. Okay, very good. Okay, the denominator. Okay, Cindy, do you see it?
Oh, yeah.
Yeah, okay. So think about what we did before, okay? Let me erase that first. Okay, thank you. Yeah, so over there, right? When we go up, the domain we said it cannot equal to 2. So when you try to find the domain, you have to look at the original. Okay? Look at the green circle. So before anything canceled out. Otherwise, you ignore the question, right? You have to include the past, right? Cannot forget the past, right? So before before the canceled out, you still have x minus 1 in the bottom, right? So you have to include restriction for that. All right. So what about the range then? Tiana, how do you find the other value for y cannot equal? X cannot equal to 1. Yeah? What did you say?
I'm not sure.
Not sure. Okay, it's okay. How about Eric? Do you know how to find the other y value?
I don't know.
Okay. Cindy, do you know?
1.
Also 1. Y cannot equal to 1.
Wait.
Huh? What?
Yeah, wait.
How did you get 1?
Because it's on the top.
Because it's on the top. Oh no, not because of that. Okay, nice try though. Okay, so let's go back. Okay, Donna, how about you? Did you also get 1?
No.
What did you get?
I got something different.
What do you have?
5 over negative 3.
5 over negative 3. Okay, can somebody else figure out why is it 5 over negative 3? 5 over negative 3 is correct, but how did we get that? Can anybody else explain? Where is that come from? Tiana, what do you think? Are you able to see where's the 5 over negative 3 come from?
No.
No? Okay, Eric, how about you?
No.
Okay, Cindy? where is the 5 over negative 3 come from? Yeah, Cindy, are you there?
Yeah.
Okay, yeah. Do you know where it came from? 5 over negative 3.
The the quotient of coefficients of units. I don't know.
Where? Where is that? Where is quotient and coefficient? Quotient of coefficient, that's for horizontal asymptote. We are past that.
Oh. I don't know. 2 plus 3 minus 1 minus 4. I don't know.
2 plus 2
I
plus.
don't know.
Yeah, I think you're almost there. Okay, so let's recap. Okay, now I got your attention. Okay, let's go back. This is the key point, right? How to find the value. So look at here. Look at the previous question. First, we found, because of the restriction, right, of the original, we found x cannot be 2, right? Because that's what's canceled out, right? X minus 2 is canceled out. And then you use that same number, the 2, to find the range. And how we find it is to take the 2, right, and sub into the function that you simplified, right? Because the POD, okay, the point of discontinuity is on the graph that you are drawing. So that's why you need to sub into the graph. Got it? Okay, so back to here, use the 1, right? The 1, right? The 1 came from the x minus 1. Okay, and then now to find the 5 over 3, 5 over negative 3, you need to sub, okay, make sure you write this down, okay? You need to sub x equal to 1 into which function? Eric? Where do we need to sub x equal to 1 into?
Graph.
Where is, what's the equation?
2 times 1 plus 3 over 1 times 1 minus 4.
Yeah, okay, so you need to sub into the function you are graphing. Okay, so you put 1, 2 times 1 plus 3 over 1 minus 4. Okay, that's how you find the 5, negative 3. Okay, so everything came from the factor that you canceled out. You canceled out the x minus 1, give you the 1, and then you use the 1 sub into the graph. Okay, do you understand now, Tiana?
Yeah.
Yeah, okay. All right, so let's add in the real number, right? X can be real number at the back, right? Y can be anything else. Okay, and then x-intercept. Okay, where is the x-intercept now? Donna?
Negative 3 over 2.
Yeah, x equal to negative 3 over 2. Remember, do not tell me x equal to 1, right? Remember, x minus 1 is gone, okay? Only focus on the graph, right? And then y-intercept is when x equal to 0. Cindy, do you have the y-intercept?
3 over negative 4.
Yep, okay, y equal to 3 over negative 4. So the POD, okay, Samantha, where is the POD then? Do you know? Okay, Eric, do you know where's the POD then?
No.
Tiana, how about you?
Is it 1 and negative 5 over 3?
Yes, okay. the POD happens at the place where you get canceled out, right? You canceled out x minus 1. That's the location of the POD, okay? X minus 1 canceled out, so you know it's at 1. And when x equal to 1, you get y is 5 over negative 3, okay? That point is on the graph. Eric, do you understand now?
Yeah.
Yeah, okay. So same thing before, right? Try to look back and forth. The POD that you got, 2, 4. 2, 4 is inside the domain range, right? Cannot be 2, y cannot be 4. Okay? So POD. Okay, finally, let's draw the picture. So this time we have vertical asymptote at 4, so we put 4 in the middle. Let's just graph 1 point on each side then, okay? 3 and 5. Okay, horizontal asymptote is at 2. Okay, 1, 2, 3, 4, 5. 1, 2. Okay, so please complete the table. Okay, you can raise your hand when you find the two values, okay, for 3 and 5. When you are graphing, right, when you plug in the value, the 3 and 5, it should go into the graph, okay, the circle one. Please do not plug into the original, okay? That's why I circled it. The original is only used for finding the pod, okay? When something canceled out, you use it to find the pod and also the domain range, right? In the domain range, you also have the pod. Please raise your hand if you finish the table. Okay, Eric, what do you have for 3?
-9.
-9, wow, okay. And then for 5, Cindy?
13.
13, okay, really big, all right. Okay, right, so just approximate then, okay? So 3, -9, 1, 2, 3, -9 is really low. Let's say down here. 5, 13, so really tall up there. Okay, so we know the graph will be in the bottom left and top right, right? And we also have intercept, okay? We can graph that too. X-intercept is at -3/2. So that's like over here, right? X-intercept. Y-intercept is at -3/4. So about here, right? So you can see that it's bending, right? This way. Okay, so we have 2 intercept, and then the other side we have top right corner will go something like this. Okay, so you will need to extend the asymptotes. Now we need to place the POD, okay, the pod. So where is the part? The part we found is at 1 and -5/3, right? So let's go to the graph. 1, -5/3. So you can see that it lands on the graph, right? So there is the part. Okay? So when you draw the curve, okay? So we need to keep it empty, right? That's the part. Okay, can you raise your hand if you finish the drawing? Donna, yeah. Okay, so that's all, right? So you need to know how to find the part. Make sure you study these 2 questions a couple times before you do your homework, all right? And make sure you check the types before you begin. All right, so that's all for tonight, and I'll see you next week, okay? Bye-bye, everyone.
Bye.
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 Bye-bye.